Hi there. Today we are going to take a look at doing some dihybrid crosses. Now I want you to keep in mind that di means two. So in this case we're going to look at passing on two different traits at the same time as compared to what we have been doing, which were monohybrid crosses, looking at passing on one trait at a time. Okay, so our information stated here says that the carnivorous dinosaurs' claws are dominant to no claws, and then sharp teeth are dominant to dull teeth. Use this information to answer the questions that follow. Okay, so our first question says that we want to cross a dinosaur that is homozygous for claws and sharp teeth with a dinosaur that has no claws and dull teeth. Now remember, homo in this case means the same. Okay, so before we answer this question, let's create our key. Now it says claws are dominant, right? So two uppercases, homozygous, will give me claws. But what else will give me claws? One uppercase and one lowercase, right? Remember, as long as we have one copy of that dominant allele, the dominant trait will be expressed. Okay. That means two lower cases would be no claws. And then for teeth, sharp teeth are dominant. So two upper cases will give me sharp teeth. I'm not going to fill that out because I don't have much space. But then I can also be heterozygous, one uppercase, one lowercase, and I will still have sharp teeth. Okay, that means two lower cases would give me dull teeth. Okay, and I remember the only time we see a recessive trait is when we have both copies of the recessive allele, and we use lower cases to represent that. Okay, so let's figure out our parents' genotypes. Now I am homozygous for claws and sharp teeth. Homo means the same. So my first parent has claws, the two upper cases, and they're homozygous for sharp teeth. And then the other one has no claws. No claws is recessive. Okay, and dull teeth, two lower cases. Okay, now I need to fill my Punnett square. But before I do that, I need to figure out the gametes. Now remember, we're looking at two traits at the same time, so it's not as simple as we just split them up C, C, T, T. No, you need to figure out your allele combinations. So what combinations of C's and T's that you have that you can put outside your Punnett square. Okay, think meiosis. So we use something called the FOIL method, and I'll put that up here. FOIL, okay, stands for first, outer, inner, and then last. Okay, so my first combination here, I have first C and my first T. So my first combination is that outer, my outer C and then my outer T. Or you can think of it as girls and boys at a dance, right? These are the girls, these are the boys. Now this girl, she has the option to dance with this guy, right? But she also has the option to dance with this guy. Same thing for this girl. She has the option to dance with this guy, but she also has the option to dance with the other guy. Okay, now in this case, we get, no matter what we do in our FOIL method, we get four combinations of uppercase C and uppercase T. Now if we apply the FOIL method here, it's the same thing, right? Because we just happen to have the same alleles in this question. Okay, then I plug these in on the outsides of my Punnett square. Okay, so I have, see, So remember, you can only pass on one copy of an allele from mom and then one from dad, right? So you can get one C and one T from mom and then one C and one T from dad. Okay. And then when you fill your Punnett square, remember you keep like alleles together. So my C's are going to stay together and then my T's are going to stay together. Okay, so uppercase C, lowercase c, uppercase T, and then lowercase t. Now because I have the same things on both sides, every single box will have the same combination of alleles. Okay. Now this is going to give me claws according to my key and then sharp teeth. So the probability of claws and sharp teeth will be, if you count these boxes, I have 16. So 16 out of 16 or 100%, right? That means all these others are 0. Okay, we'll stop there for today.